Hi, how are you? Today let's begin to study the unit of astronomy. And in this lecture, let's study the solar system. What is the solar system? The solar system consists of the sun and all the objects moving around it. And the most important objects of the solar system are the sun and the 8 planets. And this is an overview of the sun and the 8 planets. Okay, you are required to remember the names of the 8 planets. What are they? Okay, let's list them. Okay, from the closest one to the furthest one. Okay, first, Mercury moves on this orbit, and then Venus moves on the second orbit, and then Earth moves on the third orbit. Mars moves on the fourth orbit, and Jupiter moves on the fifth orbit, and Saturn moves on the sixth orbit, and then Uranus, the seventh one, and Neptune, the eighth one, the outermost one. Okay. Between Jupiter and Mars, there is a ring. Okay, this ring consists of millions of rocks, and each rock is called an asteroid. So this ring is called the asteroid belt. Okay, so the asteroid belt consists of millions of rocks, and these rocks are called asteroids. Got it, right? The sun, the 8 planets, and the asteroids are all on the same plane. Okay, this is also a characteristic of this solar system. Got it, right? Okay, so let's move on to study classification of the 8 planets. The planets, the 8 planets, can be classified into 2 classes, the terrestrial planets and the gas giants. And who are the terrestrial planets? Alright, these 4, the inner planets. Why do I call them the inner planets? Because they are within the circle of the asteroid belt. So they are the inner planets. And they are also called the terrestrial planets because on the surface of these planets there are rocks and soil. Rocks and soil means terrestrial, right? Okay, so they are classified as terrestrial planets, and they are Mercury, Venus, Earth, and Mars, right? Okay, these planets are the terrestrial planets. And then the other 4 are classified as gas giants. Okay, first, because the major ingredients of these planets are gases, and their size are much greater than that of these terrestrial planets, right? So they are called gas giants. They are so large that they are called giants, right? And their ingredients make them gas giants. Okay, they are Jupiter, Saturn, Uranus, and Neptune, right? Okay. The solar system is so enormous that we do not use the SI unit, which is a meter. We do not use a meter to measure the distance between the objects. Okay. We use a new unit called AU. Okay, AU. It is Astronomical Unit. Okay, so Astronomical Unit. So what is a Astronomical Unit? What is 1 AU? 1 AU is approximately 150 million kilometers. It is the average distance from the Earth to the Sun. Okay, this is the Sun and this is the Earth. So this distance is called 1 AU. Got it, right? So the distance between Mercury and the Sun is much less than 1 AU. And the distance between Venus and the Sun is also smaller than 1 AU. But the distance between the Sun and Mars is greater than 1 AU, right? Okay, so now you know AU. And this unit is very convenient for us in this astronomy, okay? Then, now let's take a closer look at the 8 planets, okay? First, you may be required to list the 8 planets from the closest one to the furthest one. Now are you able to list them? Yeah, they are here, right? Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, right? Mercury is 0.4 AU away from the Sun, and Venus is 0.7 AU away. Earth, of course, it is 1 AU away, right? This is the definition, right? It is 1 AU away. And Mars is 1.5 AU away. Jupiter 5 AU away. Saturn about 10 AU away. Okay. Uranus 20 AU away, and Neptune 30 AU away. So the size of the solar system, or say the radius of the solar system, is at least greater than 30 AU, right? Okay. And then how about the size of the planets? Okay. You know the size of Earth, the radius of Earth itself is about 6,400 kilometers, right? 6,400 kilometers. Okay. Venus is almost the same size, right? Venus is almost the same size as that of Earth. Okay. Mercury is much smaller than Earth because this radius is about 1/3, right? It is between 1/3 and half. Okay. How about Mars? Mars is about half, right? Mars is about half the size of Earth. Then how about the volume? Since these data are about radius, right? How about volume? Volume, okay, because volume is the cubic of the radius, right? So since this is just 1/3 of Earth, then its volume is just 5%, okay? Because 1/3 to the power of 3, it is 1/27, right? 1/27 is close to 1/20, which is 5%. So the volume of Mercury is about 5% of that of Earth. And so is the mass. Okay, so the mass of Mercury is just 5% of that of Earth. Okay, since all these rocks, these terrestrial planets, they have relatively the same density, right? They have almost the same density. So from the mass, you can see the volume, right? From the mass, you can see the volume. So the mass is just 5% that of the Earth. And Venus, of course, almost the same, right? Venus almost the same of mass as Earth. Okay. And Mars, how about Mars? Mars is about half, right? Half, the radius is half. Then half to the power of 3 is 1/8, right? 1/8 is about 12%. So the mass of Mars is about 12% of that of Earth. Okay, got it right? Okay. So is the volume. Okay. As for the gas giants, they are much larger than Earth, right? For example, Jupiter is more than 10 times greater than Earth. I mean the radius. Saturn is exactly about excuse me, 10 times the radius of the Earth, right? Okay. 10 times the radius. Then how about the volume? Volume is 1,000 times greater, right? 1,000 times greater. However, the mass is not 1,000 times heavier because this is gas, right? They are gas giants, so this is gas. Okay, so the density is lower. So the mass is just 300 times greater than Earth. And Saturn is just 100 times greater than Earth. And Uranus just 14 times greater. And Neptune 17 times heavier. Okay. but the size radius is a few times greater, right? A few times greater. Okay. And then let's take a look at the temperature. From Mercury to Neptune, the temperature is lower and lower, lower and lower, right? And Mercury is too hot, right? Venus is also too hot, and these gas giants are too cold, right? So these planets are all hell, right? So don't think about immigration to these planets, right? Okay. How about Earth? Earth is paradise, right? 17 degrees Celsius. Okay, it is paradise. How about Mars? Mars is a little bit too cold, right? Okay. Average temperature is negative 63. Then the poles, on the poles, the South Pole and the North Pole, of course the temperature must be lower, right? Since temperature must be lower, then that means colder than Antarctica, right? On Earth, Antarctica on Earth. Okay. Then how about the areas around the equator of Mars? Must be higher, right? Since some places are colder and then some places are hotter, right? Okay. So the areas around the equator of Mars should be warmer than negative 63 degrees Celsius. So for example, negative 10 degrees Celsius, you can survive, right? You can survive such environment. So Mars can be a place, maybe a destination of your immigration. Okay, so you can think about colonizing this planet, right? Okay. As for this one, no, right? Too hot, you will be burnt into charcoal. Okay, this one you will also be cooked there, right? Okay, and here too cold. Okay, you will freeze. So and you cannot live on the surface of gas, right? You cannot live on gas. Okay, so don't think about these planets. Okay, and don't think about these two either. Okay. Okay, a question. This is not the closest one. Venus is the second closest one. However, it is the hottest place. Why? That is because of the greenhouse gas, the greenhouse effect. Okay, we will talk about this a little bit later. Okay, but the big change is that the further away the colder, right? This is so why are these gas giants cold? Just because they are far away, right, from the sun. Okay. And why is Mercury hot? That's because it's too close to the sun, right? Okay. And why do we have good temperature? That's because our position is the perfect place. Got it, right? Okay. And then how about the rotation of these planets? Okay, it takes the Earth 1 day to have one rotation, right? Or say 24 hours have one rotation. How about Mars? Mars also takes almost 24 hours to have one rotation. So this is a second reason for immigration, right? So it is this is another good reason for immigration to this planet. Okay. Mercury rotates too slowly, right? This Venus also rotates very slowly, and the gas giants rotate a little bit fast, right? They take about it takes them about half a day to have one rotation. Okay. And then how about the revolution? Revolution means moving around the sun. Okay. It takes the Earth 1 year to move around the sun, right? It takes about 500 days for Mars to have one cycle. Okay. And it takes about 80 days for Mercury to have one cycle, and about 200 days to have for Venus to have one cycle. So this means the further away from the sun, the more slowly they move, right? The more slowly they move. Okay. Look, 80 days, 200 days, 360 days, 500 days, 12 years, 30 years, 85 years, 84 years, sorry. And 165 years to have one cycle. Okay, so they move more and more slowly around the sun, right? Okay, got it, right? You know this trend, got it, right? Okay, good. And how about the moons? Oh, this is also a good reason, right, for you to think about immigration to Mars, because 500 days a year, that's not too long, right? Okay. Then let's take a look at the moons. Okay, the terrestrial planets have no or few moons, right? And the gas giants have many moons, right? Okay, we have one moon. Okay, Mars has 2 moons. Mercury has no moon, and Venus has no moon either. Okay, and the gas giants have many moons. As for these numbers, it's not necessary to remember. Okay, but you just can imagine this. Okay, since they have many moons, this is we can say that they are minor. They are minor. So the gas giants are minor solar systems, right? They are similar to the solar system. Okay, they are they seem to be minor solar systems. Okay, and the composition of the gas giants are also similar to that of the sun. Okay, and then the sun have many planets, and these gas giants have many moons, so they are similar to the solar system, right? Okay, so they seem to be minor. They appear to be minor solar systems. Okay. And then let's take a closer look at the 8 planets. Okay, first, this Venus. Sorry, this is not Venus. This is Mercury. Mercury, okay, has no atmosphere. So it is bombarded by asteroids and comets. Okay, so you can see the scars, right? The scars. So this means it has no protection of the atmosphere. Okay. And then the temperature varies a lot, right? In the night, it is negative 180 degrees Celsius, and in the day it is 400 degrees Celsius. So in the night too cold, right? And in the day too hot. Okay. Then how about this Venus? Venus looks smooth, right? It appears smooth. How come? That is because it has a very thick atmosphere. The atmosphere consists of carbon dioxide and nitrogen. Okay, this carbon dioxide is very thick here. The density of carbon dioxide is very high. Okay, so this means the greenhouse gas effect is very effective. So it is the hottest planet. It is even hotter than Mercury. Okay, so the temperature, surface temperature, is over 450 degrees Celsius. It is the hottest planet. Okay, and we need to remember that this the size of Venus is the same of Earth's, right? So it is called the Earth's twin. Okay, twin sister. It is Earth's twin sister. Okay, now the Earth has an atmosphere, right? The atmosphere is nitrogen and oxygen. You know this. 78% and 21%, and 1% is the rest, right? Okay. And the Earth is mostly covered with water, right? So there is life on Earth. Okay. So you know these characteristics of the Earth, right? Okay. So let's move on to Mars. Mars also has an atmosphere. The atmosphere is carbon dioxide and nitrogen, but the density of the atmosphere is low. Okay, it is low. Okay, so this means it leaves space for you, right? So you can create oxygen here. If you manufacture oxygen here, so the atmosphere can be thicker, right? So the atmosphere would become carbon dioxide and nitrogen and oxygen. So it would be good for living, right? Okay. And it looks red, so reddish. Okay, it is reddish due to iron. So this means it has abundant iron here. So the abundance of iron is high here. Okay, so it looks reddish. Okay, and there are ice caps on both the poles. Okay, look at the North Pole and the South Pole. They are white, right? So they are ice caps. So there is also water here. So this is another reason, right? One more reason, the sixth or fifth reason for you to consider, right? Immigration to this planet, because you have water, okay, and you also have good atmosphere, right? This atmosphere is also similar to that of the Earth's, right? If you make oxygen, then it is really similar, right? Oxygen, nitrogen, and carbon dioxide. Okay, so there are many reasons for you to think about, right? Think about moving to this planet. Okay. However, now it is still hell, right? Only Earth is paradise. So, question: how come you move to hell if you can live in paradise? Okay, this is the question, right? You can write an essay, okay, about such a topic, okay, about immigration to Mars. Okay, then look at now let's look at the gas giants. Okay, this is Jupiter, right? Jupiter. Okay, on the surface, okay, on the surface of this planet, there is hydrogen and there is helium, okay, and this is the largest planet, okay, and this reddish spot, is larger than the Earth, okay, so this means that this planet is very large, okay, it is the largest one. And then the next one is Saturn, right? This is Saturn. Okay, the most important, the most remarkable characteristic of this planet is its ring, right? It is easily identified by its elaborate system of rings. Okay, so you can clearly see the rings. Okay, and how about the atmosphere of this planet? It also consists of hydrogen and helium. So actually all these gas giants have hydrogen, helium, hydrogen, helium, hydrogen, helium, and hydrogen, helium, right? They all have hydrogen and helium, so they are actually similar. Okay, but Saturn is more similar to this Jupiter. Okay, but this Uranus and Neptune, they are more similar because they both look blue, right? They both look blue, but they do not look blue. How come? Why do they look blue? Because they have one thing more. They have more methane here. Okay, so they in their atmosphere there is hydrogen, there is helium, and there is also methane. Lots of methane, actually, lots of methane. And methane can absorb red light. So when the white light comes to this thing, then the red light is absorbed, so only the blue light is reflected to your eyes, so it looks blue. Okay, so is this Neptune, right? You can use the same reason to explain this phenomenon, the color of this one. Okay, it also has hydrogen, helium, and methane. Okay, very similar to Uranus. Okay, so they are very similar, and they are also similar, right? So if these four gas giants, you also classify them, then these two, they are one group, right? And these two are also another group. Okay, so there are two groups of gas giants here. Okay, and then now let's come to another topic. Okay, in the solar system, actually, there are also other objects. So another class of objects are dwarf planets. Okay, dwarf planets. So Pluto, when I was young, Pluto was still a planet. So people still consider Pluto as the ninth planet. However, now actually in 2006, it was kicked out of the family of the planets. So Pluto now is a dwarf planet. How come? Because Pluto does not meet the criteria for a planet, because its tilted orbit Okay, so the orbit, this red one, is tilted, right? This orbit is not on the same plane, okay, on which are the sun and the other planets. Okay, the tilted orbit crosses Neptune's orbit. Okay, here this is the intersection. Okay, that is also the intersection. So it crosses the Neptune's orbit. Got it, right? Okay, so just because of its tilted orbit, okay, so it is not a planet anymore. It is a dwarf planet. Okay, and currently there are 5 recognized dwarf planets. They are Ceres, Pluto, Haumea, Makemake, and Eris. Okay. If you have good memory, then remember all these 5 names. If you don't have good memory, then just remember Pluto. Okay. Ceres, it's easy to remember, right? Ceres. Okay. Haumea, it's also easy, right? Haumea. Makemake, this is funny, right? This is funny. Makemake. So you can still remember this name, right? Eris, this is a good name, right? Very beautiful name. Okay, so you can also remember this name, right? Okay, so the 5 names you can, I believe you can remember all these names, these 5 names. So if you are asked to list 5 dwarf planets, then you can list all of them, right? Okay, good. And then, as I said, in the solar system, there are other objects, right? Now let's remember 4 names. First, asteroid. So what is an asteroid? You know, it is a rock that moving around the sun, and it is located in the asteroid belt, right? So this is a asteroid. Okay. Then meteoroid. What is a meteoroid? A meteoroid is a rock. Okay, it's a rock in the solar system that is flying. Okay, flying randomly. Okay, in the solar system. So it is a meteoroid. Okay, and the if a meteoroid is moving, okay, moving toward our Earth, and when it comes into the atmosphere, then you see the shooting stars. Okay, these shooting stars. Okay, then these shooting stars are called meteors. Okay, so what is a meteor? A meteor is a shooting star, and you are asked to explain what is a shooting star. It is when a rock comes into the atmosphere of our Earth, then it scratches the atmosphere. So there is a friction between the rock and the air, and then because of the friction, the rock becomes very hot and it evaporates. So the evaporated gas, okay, releases light, so we can see it. So we can see it light. Okay, so that's meteor. So what is a meteoroid? Meteoroid is a rock. Meteor is in the atmosphere, right? And then the next one is meteorite. So what is a meteorite? A meteorite is a stone, a rock that has already reached the surface of our Earth. Okay, so it has already reached the ground of our Earth. So it is called a meteorite. Okay, so now you know the 4 names, the difference between all these 4 names, right? Asteroid, meteoroid, and meteor, and meteorite. Okay, a asteroid is not a meteoroid. Okay, a meteoroid is moving randomly. It's not moving around the sun. Okay, got it, right? It is moving toward our Earth, and the meteor means it has already entered the atmosphere, and it is giving off light. And a meteorite means it has already reached the ground of our Earth. Okay, got it, right? And then actually the meteoroids and the meteors and the meteorites, the origin of those objects are actually comets. Okay, so a comet, what is a comet? A comet is a object that moves around the sun, but it has a very long elliptical orbit. Okay, so when it is far away, we cannot see it. Okay, but when it comes close to the sun, then we can see it. And because its composition is rocks and ice and ice or solid carbon dioxide. Okay, so when it is close to the sun, the carbon dioxide and the water, the vapor, will become vaporized, evaporated, right? It becomes gas. They become gas, and then because of the solar wind, the blowing of the solar wind, okay, then the vapors leave the surface of the comet, so it becomes a long tail. Okay, so we can see the long tail. Okay, and the tail seems to be moving away from the sun, right? Look, they point away from the sun. Okay,